Cresta is I want to say like 99.9% Kubernetes company. So we have Lambdas and, various things here or there, but the overwhelming majority of our compute is Kubernetes. That happens to be in AWS, in EKS, which is their managed Kubernetes offering. And so the most important thing to us was finding a solution that really worked well in that Kubernetes environment. It's very important. There's lots of monitoring stacks that work well because you install agents on your virtual machines and stuff like that. And while that can work in a Kubernetes scenario, it was really important to have a Kubernetes first type of approach. There's a lot of monitoring companies that will say, hey, we monitor your EC2 instances, we'll monitor your VMs. And the way we do this is by installing some agent that's running on the virtual machine. And that's going to collect all this data and send it over. And now you've got your monitoring, right? But this really gives us that would give us a very fragmented view of what our stack actually looks like, because in order to really understand how these things are performing, you have to look deeper. You have to look into the actual Kubernetes API and see what workloads is this VM actually running. Like, is there a reason, for example, you might get an alert that says, hey, your VM's only using like 50% of its CPU. Like, you could maybe use even more than that if you wanted to, but it doesn't quite work that way with the way that the Kubernetes scheduler works. In the sense that, if you look at the Kubernetes level, you might have all these workloads running on this VM that are requesting, as much CPU as they can, and maybe they just have a little bit of an idle point at this time, right? And so you kind of have to look deeper than just like the hardware level metrics like CPU and memory utilization. You have to go into scheduling, you have to go into CPU requests and memory requests and stuff like that, and you have to think of how these things kind of react when you deploy new workloads to Kubernetes, I guess. And so having that understanding of being in that Kubernetes ecosystem, I think leads to a better product that's more Kubernetes focused. With the eBPF functionality of groundcover, now we sort of have, because of that deep level of understanding, we actually have a pretty good picture of how our services interact with each other. Whereas if you were looking at the AWS UI and you just saw like 200 EC2 instances, you don't really know what's going on there, right? Like, it's just, hey, we got a lot of compute, and some of them are G6s, they're running GPUs. Some of them are, I don't know, M8 instances, right? Like, you don't really get it, right? But then when you integrate with the actual underlying workloads that we have, and especially when you have that eBPF level tracing, you really get a complete picture of what's actually running, which is really hard to do sometimes with Kubernetes. The space evolves really quickly. We evolve very quickly as a startup. And so sometimes it can be hard to keep track of what services there are and what they talk to. And especially like documentation is always very slow to come by. And so having that just right there is super valuable to us. There's always sort of been a mentality at Cresta to do things on our own. We do that a lot for a lot of different things. We have a few vendors that do things that are really hyper specialized, that would require a lot of engineering effort for us to kind of do our own implementation of it. And we were kind of considering doing that open source, right? But our initial experimentation with that, it was actually really difficult to get that stack working the way that we wanted it to. Their docs are kind of all over the place. I think they release lots of updates very frequently. And as a result, you never really know if you can trust their docs at this current iteration. It doesn't seem like those evolve as quickly as their products do. Their stack was rough to deploy. We kind of experimented with that, didn't really like where that was going. And so we kind of took a step back and started evaluating like who we could potentially partner with to kind of give us sort of that same scenario. And I think what really sold us on groundcover was, I think that the experience that we get for being Kubernetes first is really good. We really like a lot of the open source tooling that's kind of running behind the scenes, especially ClickHouse. We have a lot of in-house ClickHouse knowledge because we run our own ClickHouse clusters for a variety of reasons. And so having that on the back end and giving us the ability to like query it directly and stuff, a lot of our engineers, especially including myself, really appreciate and enjoy. But really, I think the main thing for us was the Kubernetes first stuff, just to hit back at that. And I think the eBPF tracing is like a really unique thing that not a lot of, I don't think any really observability partner had a solution for. There's been a number of times where someone was saying, hey, like we're interacting with this third party like contact center API, and they sent us back this payload that was clearly a bug on their end. but we can't like prove it to them because we don't actually have a record of what we sent them, because we don't have logs that encapsulate requests that we sent to third parties. And I say, well, actually, we do have traces. And I showed them the exact trace, and they saw the exact body that they could actually send off to our contact at this company that we work with. And not only do we have the traces, but we can actually make alerts on those traces because all that data is in ClickHouse too. And so I was able to show them, here's the documentation I wrote for how to query this data in ClickHouse. So here's how you can go in Grafana and you can set up these alerts, and you can use the data from these sampled traces to say, hey, if you ever see a trace that has a body that has this particular payload that looks like this, then alert us, because that means there's another bug that kind of caused an outage for one of our customers. And so there's been a number of times where that's come in handy. And so I think that points to us making the right decision there. The installation process, in terms of just like, let's run a command and just go, is very easy. And again, it's because of that Kubernetes first stuff, right? So we're already very avid users of obviously Kubernetes, but deployment tools like Helm, for example, and groundcover has a Helm chart. And so that just works, right? So we just run the Helm chart, we deploy, and we're kind of off to the races, right? I think it was really valuable in just, okay, we don't really have to spend most of our trial, like a week or so, just setting things up and getting things to the point where they actually can work. The Helm chart kind of comes with, I think, some pretty sensible defaults to say, hey, this is a application that works at least far enough to get you to the point where you can see where the value is in the platform. And then the productionalization of it kind of came later, where we started thinking, okay, well, what we really should do is build out our OTel pipeline, kind of run some of our own infrastructure on our side, and then having groundcover be the final destination of that. So there was some work beyond the trial that kind of got us to a place where we were really happy with seeing that data kind of progress through our own pipeline, and doing things like aggregating metrics or adding labels to certain things on metrics, and then having groundcover kind of be that final destination. But getting started was, relatively easy with that Helm process. There really wasn't a lot to talk about there, which maybe I think is a good thing. It's like the complete package at a really fair price and not predatory price. So when we spike up to a ton of instances overnight to run a bunch of batch jobs, we're not punished for it, because it's the average over a month. So we get logs, we get traces, we get metrics. Those are kind of like the three things that people care about. But it kind of goes beyond that, because it gives us the eBPF insights into things that we wouldn't normally have, and it gives us the ability to query those three things, those logs, traces, and metrics, to query those in a way that we really haven't been able to do before, which I think is really unique, I guess, especially doing it with ClickHouse, which has been really good for us because we're already avid ClickHouse users, and so it's kind of right up our alley. And in some cases, you can even combine the results of one query to the other. So I guess the flexibility of having the data but being able to query it in a really effective way. We have so many nodes, we run so many GPUs because AI requires a lot of compute nowadays. But if you don't have that and you're a startup that has like a 10 node cluster and your product is some web app, which is fine, there's nothing wrong with that. But then if your product is simple in terms of the architecture that you have and the infrastructure that you require, then you're probably paying very little for, in my opinion, a really great product.